Conditions for the balance of a special system of forces is lesson number 215 from the book Mechanical Systems Calculations of the Marine Facilities. We can consider vector and the scalar forms of the balance equation of the systems of forces. So first of all, about the special system of forces, we have necessary and sufficient conditions for balance of special system of forces, which are the system of forces. We have here F1, F2, etc. Fn have to be equal to 0. That's a condition of the equilibrium of the system of forces. In the vector form, this corresponds to the equality to 0 of the resultant of the indicated system of forces. And resultant, and we have to have the resulting moment of system of forces as well, vector, have to be equal to 0. Besides, we have scalar form of necessary and sufficient conditions of the balance for special system of forces, and the magnitude of the resultant have to which is equal to the square root of total of the projections of the resultant on the axis. So three summands are x projection on the abscissa axis squared plus ry squared plus rz squared. This resultant have to be equal to 0. This means that each of summand have to be equal to 0. That is the projections of the resultant force on the abscissa axis, on the ordinate axis, and the applied axis have to be equal to 0. And the second necessary and sufficient condition is that the moment of rotation of a mechanical body around the definite point, around the arbitrary point, is not so much important because we know that the vector of the moment are the free vector, so point of the application can be any. On the contrary, with the resultant force that it is sliding vector. We can move it in any point of the application along the line of action. So the resultant moment have to be equal to 0. That is magnitude of the resultant moment in the scalar form of the balance of the equilibrium equation of the body under the special system of forces. The magnitude of resulting moment is square root of three summands mx squared, my squared, and mz squared. That is each of the projections mx, my, and mz have to be equal to 0. Definite cases, particular cases. The necessary and sufficient conditions of balance of solid body under the influence of the arbitrary system of forces. Yes, we consider that it do satisfy in the scalar form that the all of projections of forces on the abscissa axis, on the ordinate axis, or the applied axis have to be equal to 0 each. And we know that the projection of total of all projections of forces on abscissa axis is the projection of the resultant. And all the total of the projections of all forces acting arbitrary system of forces on projections them on the ordinate axis all together as total is equal to the projection of the resultant force on the ordinate axis, and the same about the projection of about the total of all projection of forces acting on the mechanical system or body, all projections on the applied axis equal to 0. This means that each of this total of the projections of all forces on the applied axis is a projection of the resultant of the acting forces. As well, the projections of the moment rotating the body around the point 0. Any reference point, we can take it arbitrary. Necessary and sufficient conditions of balance of body under influence of the special system after a special system of parallel forces, as is shown on the figure 2.15.1. parallel system of forces, so these forces do not cause the rotating moment around the axis applicate z, that because the rotation we have only if the forces are perpendicular, do not cross. If only the forces are not parallel and do not cross the axis of the rotation. So these forces are parallel. So if for the parallel system of forces we have three sufficient necessary conditions of the equilibrium of the system of forces. The first is that total of projections of forces on applicate axis have to be equal to zero. Yes, because these projections on the abscissa and the ordinate axis are zeros each. So the total is important to find only of the projections on the axis of the Cartesian system z ordinate axis, applicate axis, excuse me. And the total of moments rotating the body around the x-axis are about actually any axis parallel to abscissa. And the total of moments rotating the body around any axis parallel to ordinate axis. And the necessary and sufficient conditions of balance of a body and the influence of a spatial system of convergent forces. We know that convergent forces do not cause the rotating moment in the space around the definite moment point, the point of reference here on the figure 2.15.1b. The convergent system of forces do not cause the moment rotating around the reference point 0, reference point of the Cartesian system of coordinate. So the conditions of the equilibrium of the system of forces sufficient and necessary conditions are that all projections of forces on abscissa, the total projection of forces on abscissa axis, total of projection of forces on the ordinate axis y, and the total projection of forces on the axis z have to be equal to 0 each. Although we do not consider the equilibrium by moments as the moments we know for sure is 0 relative the point reference point z, 0 and relative any other point, as we know that the moment is a free vector and can be applied to any point. Next, particular cases of the balance of system of forces for the can be considered the flat system of forces. Very appropriately frequently we have flat system of forces in the mechanics during the main issues of the mechanics, like finding of the support reactions and finding the balance equations in the statics and the mechanics. So necessary and sufficient conditions of balance of body under an arbitrary flat force system on indicated example on the figure 2.15.2a have to be equal totals of all projection of all acting forces on abscissa axis and the total projection of all of forces on ordinate axis, as we do not consider the applicate axis. Yes, all that have to be equal to 0, and so the condition of the equilibrium of the mechanical system of body and the impact of this system of forces F1, F2, etc., Fn is that the total moments of all efforts, projections of efforts on the flat 0, xy have to be equal to 0. So the moments of the forces acting in the plane 0, xy have to be equal to 0. Relative any point could be the reference point, could be another one point, due to the remember that the point of the application moment is not important, as a moment, rotating moment is arbitrary moment, is arbitrary, it can be applied to any point. This means that all moments and all projection of moments, the equality of moment, it is the projection of moment relative any axis had to be equal to 0. And we cannot consider the rotating moments related to the axis that we have exactly the moments equal to 0 in the flat state, as here we have equality to 0, the moments of forces relative to the axes y and x. It's not important, but we have another one axis. This is for special system of forces. This transformed to the flat state, to the plane as just the total of rotating moments around the 0 point reference or any other reference point. Okay, and the necessary and sufficient conditions of balance of solid body under the influence of plane system of parallel forces here on the figure 2.15.2b have the form the total of all forces projections on the abscissa axis have to be equal to 0, and the total of the moments of forces in this flat state, in this plane, or the moments acting on this plane have to be equal to 0. We not consider the total of the projection of forces on the ordinate axis. This is due to these forces are perpendicular to ordinate axis and cause 0 projections on the ordinate axis each themselves. And the conditions of balance of a body under the influence of a flat system of convergent forces. Convergent, all lines of actions crossed in the same reference point could be the point 0. We just coincide the reference point of the flat system of coordinate 0, x, y. We just coincide this into the point of the intersection of all the lines of the actions of the forces considered in the system of forces. So the condition of balance of body under influence of the convergent forces have to be that all projections of forces on abscissa axis, on ordinate axis, have to be equal to 0. We do not consider the rotating moment as for convergent system of forces. The rotating moment is 0. Questions and comments. The vector form of the necessary and sufficient conditions of balance of conditions of solid body and action of the special system of force. The vector form is that the vector of the resultant and the vector of the resulting moment have to be equal to 0. Scalar form, necessary and sufficient conditions of balance conditions of a solid body under the action of a special system of force. Scalar form, that is the magnitudes of the magnitude of the resultant of the all forces action on the body have to be equal to 0. Magnitude of the rotating moment have to be equal to 0. On the other hand, this means that although each one of the projection of forces on the axis of Cartesian system x, y, z, and all projection of moment of the vector of moment on the coordinate axis have to be equal to 0 each one of the projection. No one can be not equal to 0. 2.15.3. The necessary and sufficient conditions of balance of the body under the influence of the special system of parallel forces. For the parallel forces, we remember that if the forces are parallel to definite one coordinate axis, that's why the balance condition is that necessary sufficient that all projection forces on this axis to which the forces are parallel have to be equal to 0, the total of the projections, and that to the other axis we don't consider the total of the projection of the forces, because the forces are perpendicular and have 0 projections on the perpendicular axis, and the rotating moment of these forces relative any point, could be reference point, maybe the origin of the coordinate system, the rotating moment had to be equal to 0. Conditions of balance to 2.15.4 conditional balance of solid body under the influence of arbitrary flat force system. Necessary and sufficient conditions of balance of solid body is that all projectional forces on each of in the flat state on each of coordinate axis is to be equal to 0, and on projections on each of two axes in the flat state, and that the rotating moment of all forces located in the plane of 0 x y have to be equal to 0. The 215.5, the necessary and sufficient conditions of balance of a body under influence of the plane system parallel forces is that the total of the projections of forces on the parallel axis have to be equal to 0, and the rotating moment in the plane of the action of these forces have to be equal to 0, not considering the projections on the perpendicular axis, because these projections are zeros. Conditions of the balance of solid body and the influence of the spatial system of parallel forces. Okay, it's about the same question as the previous one. And the necessary and sufficient conditions of balance is last one question. 215.7, the necessary and sufficient conditions of balance of solid body under the influence of the plane system convergent forces, because relative the point of the intersections section of lines of action of each of all forces, the same point, this convergent system of forces. In this case, they do not cause the rotation moment relative to this point of the intersection, as we know that the forces do not cause the rotating moment if the point of rotation is on the line of the action of the force. So if it is for all forces in the convergent system of forces, the rotating moment condition we do not consider as the necessary and sufficient. So we have only the condition of the forces projections on two axes in the flat state have to be equal to 0. The totals of the projections of all forces on each of two axes. Thank you very much.